Good morning. I am Shailendra Singh Ojha, Assistant Professor in Department of Electronics and Communication Engineering. Today, we are going to discuss the IC 741 and especially we will discuss the internal structure of IC 741 and we will analyze this circuit for DC. That means we will see the DC analysis of IC 741. So, before starting with the internal structure of IC 741, let us quickly revise the IC 741. What is this and what are the various uses? And its name suggests IC 741 operational amplifier. That means it is a device which works as an operational amplifier. That means this device can amplify the signal as well as it can perform several arithmetic operations like differentiation, integration, addition, subtraction, log, anti-log, as well as there are several other applications. These are the manufacturers of IC 741 like Fairchild, National Semiconductor, Motorola, RCA, Texas Instrument, Signetics. But the most famous IC is this IC 741. This is a 8-pin IC. You can see first pin is the offset null, second pin is the inverting input, third one is the non-inverting input. This is used to supply the minus VCC, that means negative supply voltage. This pin is used for the positive supply voltage. Output is taken from the pin number 6, fifth is the offset null and 8th pin is the not connected. That means this pin have no connection and 8th number pin is not used practically. And you can see this is the diagram of operational amplifier. So, whenever you want to use this IC as a IC 741, so you need to remember few things like you can give power supply at the 7 number pin and 4th number pin plus plus VDD at 7th number pin and minus VE at 4th number pin, and you will take output from 6. So, these 3 connections are fixed connections, and then if you want to give input at the inverting terminal, that means negative terminal, then you can give that input at pin number 2, while pin number 3 works as a non-inverting input terminal. This is the detail of the pin numbers. What is the use of various pins? Like first number pin is the offset null pin. Offset voltage is nulled by the application of a voltage opposite polarity to the offset. That means whenever you are getting some output at the output terminal, even though you are not applying any input, then to null that we use this pin. We can apply the voltage of negative polarity at this terminal to get output equal to 0 if we are not applying any input. Rest pins are the simple. So, I am not going to discuss it further because I have already discussed this and it is quite simple. So, let us come to the block diagram of operational amplifier. First is the input stage. This is the stage where we use differential amplifier. We use dual input balanced output differential amplifier. It provides high input impedance, it provides high voltage gain, it rejects noise. Second is the intermediate stage. It used dual input unbalanced output amplifier and it provides very high voltage gain. And third stage is the buffer stage and it is also known as level shifting stage. It generally uses emitter follower. It provides high input resistance, low output resistance, avoid loading effect and set DC level to 0. And finally is the output stage. It generally uses complementary push-pull amplifier. It decreases output impedance, increases output voltage swing and raise the current supply to the output. So, this is how we can understand operational amplifier by these 4 blocks. However, soon we will discuss the internal structure or internal architecture of IC 741. So, if you will see, this is the internal architecture of IC 741. So, first let me explain the various transistors, their use and various stages. After that, we will see the DC analysis of IC 741. You can see here there are various transistors like Q1, Q2, Q3, Q4, Q5, Q6, Q7, Q8, Q9, Q10, 11, 12, 13, 14, 15 and so on. So, let us see what are the various stages. If you will see, then you will come to know that this is the reference current generation stage. In this stage, reference current is generated. This Q12 and Q11 will form current mirror, and this reference current can be obtained whatever value you want. Soon we will discuss how we can select the particular value of reference current. After this, this is the first stage. In the first stage, there are Q1, Q2, Q3, Q4, then Q5, Q6, Q7. This is the differential amplifier, and we apply 2 inputs. One input may be at this Q1 and another at Q2. Other than these 2 inputs, in this whole circuit, we are not going to apply any input anywhere. If you will see, it is going to, these all are connected to positive voltages and these all are connected to negative voltage minus CE. And in this, this is the current mirror, this is again current mirror. They will provide constant current or biasing current for the operation of this circuit. And these 3 transistors Q5, Q6, Q7 and these 3 resistors, they whole will work as a active load. After this, this is the second stage. In the second stage, we have 3 transistors Q13B, Q16 and Q17, and after this we have this output stage. Output stage have these resistors Q18, Q19, Q23 and resistor R10 and Q13A, and this Q14 and Q20, and this shaded portion. This circuit will not come under any stage like input stage, output stage. This is different circuit which is called as short circuit current protection circuitry. Short circuit current protection circuitry. So, this circuit will protect this whole IC 741 whenever any kind of short circuit will occur. And now, let us discuss few more points related to the input stage. Like the IC 741 consists of 3 stages that we have already seen: an input differential stage, intermediate single ended high gain stage and output buffering stage. The transistor Q1 and Q2 acts as emitter follower, causing the input resistance to be high and delivering the differential input signal to the differential common base amplifier formed by Q3 and Q4. And we have already seen that Q5, Q6 and Q7, R1, R2, R3 from the load circuit of the input stage. So, this is the detail of the input stage, and you can see few things in this circuit, like this is NPN transistor and this is PNP transistor. So, we are using these two transistors in series. The reason is, whenever this device will come under reverse bias, so it will not get damaged, because the reverse breakdown voltage for NPN transistor is around 7 volt, and for this NPN transistor it is around 7 volt, and for PNP transistors reverse breakdown voltage is around 50 volt. So, these two are connected in series. So, whenever high voltage will come across these two, maximum voltage will go to the PNP transistor, and which can tolerate the high voltage. So, Q1 and Q2 can operate safely. Now, in the second stage, as we have already seen, in the second stage or intermediate stage, we have three transistors, Q16, Q17, Q13B, and resistors R8 and R9. Transistor Q16 acts as a emitter follower, and which gives the high input resistance, and this minimizes the loading on the input stage and avoid loss of gain. So, in this way you can see this is the second stage which will work. The output stage provides the low output resistance and high output currents. IC741 generally uses class AB power amplifier, and it consists of complementary pair of Q14 and Q20. So, this is the brief introduction of internal architecture of IC741. It consists of three stages: input stage, intermediate stage and output stage, as well as reference current generation stage. And these are the device parameters for PNP transistors. Reverse saturation current is 10 to the power minus 14 ampere, beta is this, early voltage is this. For PNP transistor it is like this. And while for the Q13, these are the device parameters. Now, let us discuss the bias circuit. This is the reference current generation stage, which I have already shown you in the internal architecture diagram of IC741. So, you can see here, this is the reference current. What will be its value? This voltage VCC minus voltage drop which is VBE2, and again then this is short circuited. So, these two voltages will be same. Then this resistance is there. After that it is short circuited, and then this voltage which is VBE11, and this is VEE minus. So, this reference current will be VCC minus this voltage drop minus this voltage drop, this minus VE divided by this resistor R5. So, if you will put these values like VBE 11 and VBE 12, which is equal to 0.7 volt, and if you will consider this resistor R5 is equal to 39 kilo ohm, then you will get I reference is equal to 0.73 milliampere. Now, after this Q11 and Q10, they are forming Widlar current source, and for the Widlar current source, this is the expression which we have already derived. Now there is no need for derivation, but you can remember this very easily. So in this case, you can easily find out the current, reference current with respect to IC10, R4 and VT. Actually, our purpose is to find out all the currents, and Q8 and Q9 again are forming current mirror circuit. Now let us come to the input stage and let us analyze this for the DC current. Let us consider the current which is flowing in this branch is I, then it will also be I. Then this current will be equal to collector current is nearly equal to emitter current, and this is the base current. Base current IC is nearly equal to IB. IC is nearly equal to IE, which is equal to beta IB. So IB is equal to IC upon beta. So by this you can easily write, and here actually you already know IC is equal to IE, so it is equal to IE upon beta, nearly equal to. So this current will be IE upon beta, this current will be IE upon beta. Okay. So if you will add these two currents, it will be 2I upon beta. Okay. And by current mirror circuit, this current is I, then this current should be I upon 1 plus 2 upon beta, but this current is 2I. So the current which is flowing in this transistor Q9 will be 2I upon 1 plus 2 upon beta by the property of current mirror circuit. So these two currents are the incoming current and this current is the outgoing current. So by Kirchhoff's current law KCL, you can simply write 2I upon beta plus 2I upon 1 plus 2 upon beta is equal to IC10. And if you will consider beta very large, then this current will this current or this term will be nearly equal to 0, and this term will also be nearly equal to 0. So 0 plus 2I upon 1 is equal to 2I is equal to IC10, and you can easily write I is equal to IC10 by 2. Actually, our purpose is to find out current in each and every branch. So now in this branch we are already getting current I, this is current I, this is current I, then this current will be I upon beta n, because it is NPN transistor, this current will also be I upon beta n. This current is I, this current is I, and almost 0 current is flowing in this because this current will be very small. So now you have idea about all the currents in first stage, and in second stage if we neglect the base current of Q23, the collector current of Q17 will be equal to the current supplied by Q13B. So we can then use IC17 to determine VB is 17. Okay, and finally we can say that IC16 will be equal to IE16, and for the output stage, this transistor is forming current mirror circuit with the previous transistor. So this transistor selected such that this current is equal to 0.25 times I reference. If this current will be 0.25 times I reference, then this current will also be 0.25 times of I reference, and in this way we can say that yes, we have full idea currents in all the stages. So this is how we can analyze the IC741 for the DC input. In the next lecture we will see how does this circuit will behave for the AC. Thank you.